Another one that I'm quite excited about is basically approaches that make the free energy formulation more authentically historical. Here I'm thinking about approaches that consider the time evolution of the generative model itself, or just completely moving into the path-based formulation, which I think has been a focus of a lot of the work that the community's done since about 2020. I mean, in some sense, a big part of the mathematical work, at least, that's been done on the free energy principle consists precisely in, relaxing the assumptions that were baked into, current formulations of the FEP at the time, pertaining to steady state, stationarity, and that kind of thing, and then, allowing us to talk about things like history and path dependence. Would you like to maybe comment on that? You yourself have been quite busy with the path integral formulation and its development over the last few years.
Yes. Yeah. When you talked about the history, I think we should perhaps return to that, because I think it is very interesting to retrace the multiple paths of legacy over the centuries and decades that lead to the free energy principle. I think that's a really interesting exercise. I think we should spend some time talking about that kind of history. But I get the sense that what you're talking about is the technical development and frontiers of the mathematics of the free energy principle. And you're absolutely right. There's been more and more focus on the path integral formulation for various reasons. Just to put this in context, you can approach the free energy principle, or you can derive it or frame it from many different directions that are currently available to us. I put an emphasis on information theory previously, and the route that would that kind of approach would naturally take would be in terms of statistical mechanics, and particularly stochastic mechanics, leading to a sort of an entropy production perspective on free energy minimizing processes, ultimately cast in terms of fluctuation theorems. That would be nicely complemented by an alternative approach, which doesn't focus so much on the density dynamics, but the path integral formulation. And that's certainly been a greater focus recently, because it has a number of simplifying aspects, not least those which you sort of implied, that you can relax assumptions about the nature of steady states, because if you're dealing with a path integral formulation, you already have the short-term history of your dynamics at hand, so you don't have to worry about the long-term t equals infinity outcomes and all the normal conclusions or results on applying the free energy principle now obtain in the local, in the present, but it's an extended present, escaping the specious present, in the sense that now what you're talking about is a calculus that deals with trajectories or paths that necessarily have a kind of history for the internal states that you're trying to model.
So from that perspective, no, sorry. Actually, never mind. I interrupted you. I shouldn't have.
Well, come back, because if you felt you should interrupt, you clearly have something interesting to say. I was just going to say that there are other routes to this. You could take a gauge theoretic approach. You could also, if you like, and I know that Dalton is working on this, you could take a statistical physics approach that Jaynes instantiated in his reworking of the minimum entropy production principles due to Prigogine and colleagues, culminating in sort of constrained maximum caliber principles. They're very closely related. I don't know at this stage that they're the same thing, in the sense that most of the maths in the 20th century did not have this 3 or 4-way partition, and much of the, if you like, the explanatory power of the free energy principle rests very sensitively on having not just a bipartition into internal and external states, but including blanket states into a 3-way partition, so that you now, if you like, have more than just the internal states and the heat bath, but also what contains the heat bath, and then all the interesting stuff emerges. So I've yet to, I'm looking forward to seeing people revisiting James's maximum caliber or constrained maximum caliber principles and minimum entropy production principles under the 3-way partition, which is a minimal partition that you would need in order to articulate the free energy.